Ladies and gentlemen, our next session will be a tech demo by Brendan Schulman, Vice President of Policy and Government Relations at Boston Dynamics.
All right, thank you everybody. It's great to be here. Awesome to have this day of AI and robotics policy. I am afraid that I'm going to disappoint you though in two respects. First of all, if you were here this morning, you heard from our founder, Mark Raybert, and there's just no way that I can top his vision, his history with these kinds of technologies, and the things that he's done to make this kind of technology come to life. So I'm not going to even try to do that. We'll talk a little bit about robot applications, but certainly Mark is the expert. Number two, I've brought the world's most advanced mobile robot that can traverse uneven terrain, walk up and down stairs, and open doors, but it's on a flat stage. So to me, that's a little disappointing. I do have this sort of advice to you. If you ever need to do an impromptu robot demo showing mobility, shop at IKEA. They have a terrific variety of boxes of different sizes that you can buy. I literally picked this stuff up yesterday. So we're going to do a little bit of a demo on mobility. You saw Mark this morning with the videos of Spot being kind of pushed over, kind of abused in a way. All that stuff is real. I can give Spot a little push, and it's going to self-stabilize. So I'm not going to kick the robot or hit it with a hockey stick. You can watch the videos for that. But what we will do is sort of an example here of the robot's mobility. Now again, these are plastic bins, so they're probably going to fly all over the place. But Spot is in real time just going to traverse them, walking over and around, stepping on them and over them, not really caring and not sort of having any idea about these boxes in advance. It's just in real time, figuring out where they are and taking steps. Of course, the boxes that don't weigh anything are going to move and fly around the stage. There we go. No problem. So a little bit of a demo live in real time and not on video that, of course, I think demonstrates the capabilities. Of course, Spot also, in this case, has a mobile manipulating arm. I brought a dog bone, right? So sort of from a pet store. So if we just put the bone anywhere, we have sort of autonomous functionality. All I need to do is tell the robot that I want it to pick up an object, sort of tap on the bone and ask the robot to pick it up. Spot's going to handle everything else. I'm not kind of telling it what to do or where to go or how to approach or pick up the object. That's sort of all autonomous. And once it grabs the object, I'm going to say, oh, yeah, you got it. Good job, Spot. Why don't you carry that to me, kind of turn it around, have it come over, and hand it to me. So sort of like a robotic fetch. A lot of fun. Of course, not for me, for the robot. Again, the congratulations all belong to Mark, not myself. One last thing, I know a lot of people are like, oh, the robot dances, can you make the robot dance? This is a very small stage, but just for you guys, I'm going to do a little bit of a sample dance, just so you kind of get a little bit of an idea here. And here we go. Jump. A little bit of a bow. So that is the demo portion. Thank you. Okay. Okay, I guess we need to bow again, Spot, so maybe one more. We'll bow. Traverse the chairs, maybe after hours, once we get through the reception. I do have a few things to talk about with respect to how these robots are actually being put to use in industry. We've heard a lot of great conversation today about manufacturing and defense and other applications. If I could get the slides up and running, just show you a few things. First of all, I think so much of the discussion we have on AI these days in the policy arena, also in the technology arena, are these things, what I call the intellectual output of AI. Things like art and language and healthcare, customer service, with a lot of concerns about bias and misinformation and things that we talk about a lot here in Washington. That's all great. What I love about this day is we're talking about AI in robotics. And to me, like, this is a huge part of what AI will be for us, good and bad, but also the applications and the enhancement to robotics technology is really unprecedented. And the reason why this is important and timely for us to talk about is just demographics. When you think about what's going on, and I think Mark had this at the very end of his presentation. We did not coordinate, but he was hinting at something that I feel as well, which is that the emergence of robotics in society is inevitable because of what's happening to birth rates and demographics. You see it first in Asia, you also see it here in the United States. And the answer to this, of course, is we're going to need machines to be doing the heavy lifting, doing the hard tasks of building and putting things together. Of course, robots have been around a long time. That's why you don't often hear AI and robotics talked about in the same sentence until maybe just recently. This is what robots were for a long time. Things that were hidden away in factories and maybe warehouses and other industrial facilities, doing single tasks, bolted in place, maybe welding, maybe moving things around. This era is now expanded and new with the emergence of AI-powered, highly mobile robots like Spot. And here you see a handful of applications. What's different in this slide is the environment. These are robots that are working in places where we live and work, in unstructured environments. They're not bolted in place. They're walking up and down stairs. They're opening doors. Sorry, we don't have a door up here. I can't show that to you. Maybe later on if you join me for the reception, if we can find a door. But huge difference, right, to have robots out there in the world, and that's where the AI comes into effect. Let me give you some examples of Spot actually out there in the world making a difference. Hugely important to our competitiveness internationally is semiconductors. We have a Spot deployment up at Global Foundries in Vermont. Spot is doing inspection rounds, detecting overheating pumps, reading data and information into the system. It is a way to modernize the semiconductor fabrication plant without ripping out and upgrading the systems. Rather, you have the robot doing a lot of the autonomous missions that otherwise would be done by a state-of-the-art facility. Again, that's a huge benefit to that industry. Food and beverage companies, Spot is monitoring, in this case, 1,400 inspection points, detecting potential issues, making that factory safer and more efficient than it was before the robots came into effect. Power plants, particularly nuclear power plants, that's kind of in the news. Are we going to start building power plants again, nuclear plants? Maybe. Interesting, and obviously connection there with AI and power needs. Well, robots in the factory monitoring and mapping radiation are a huge safety benefit to the workers of that facility, and that's work that's already going on with Spot in place around the world. In this case, Surrey is in the United Kingdom, but also here in the United States. Other applications, public safety. When you take an advanced robot that can walk across uneven terrain, you have great results like this. This was a kidnapped 3-year-old child in a truck that was crashed off of a highway. And the officers needed to figure out, is the kidnapper armed? Well, they sent Spot in with its cameras, able to walk off the road, look inside the cabin of the truck, and determine there were no weapons in there, and there could be a safe and effective rescue of the 3-year-old child, I'm glad to say. And then I don't know if you caught this news. This may be historic. I think it might be, at least for our company, the first time a robot has been shot in the line of duty. This was in Cape Cod, Massachusetts. It was a sort of an armed barricade domestic dispute. Unfortunately, something that happens every single day across the United States. Well, in this case, the suspect, after pushing the robot over and experiencing what you've seen in the videos, the robot getting back up, decided to shoot the robot in an attempt to disable it. Spot was disabled temporarily, though fixable, although I believe we've kept this as part of our museum collection, given the history here. But from my perspective, having a robot taking bullets instead of a person is a huge public safety benefit, and of course applicable in the DoD military context that we heard about earlier this afternoon. Let me give you an example of how we're actually putting AI to use. This is Spot falling on a slippery surface. We had feedback from a beverage manufacturing facility customer, really a beer plant, that Spot was slipping on its wet, beer-covered floors. So we used reinforcement learning, you can see before and after here, to have the robot train itself just to take those steps that you and I know intuitively and not slip when it encounters either ice or a slippery surface. In this case, it's an oil-covered plastic sheet in our lab. But you can see the difference, and this was deployed as a free update to the robot. So if we get the robots into facilities and then update them with software using AI, reinforcement learning, machine learning models, they get better over time. And this is something we're sort of proud of, and really the future of robotics, particularly as we see applications across different domains. Another example of AI techniques, Spot can walk any place where there isn't an obstacle. But in some cases, like here, you don't want Spot walking under a ladder. It's either bad luck, if you believe that, or it's just a safety hazard. So in this case, you can see the computer vision working to identify what are the kinds of obstacles Spot is encountering. It's not just a wall or a trash bin. In this case, ladders, pallets that have wheels, things you really don't want the robot to step over or walk under, even though its original programming would say, that's not an obstacle, I can get through there. So ways in which the AI reinforcement learning programming is really making a difference, and these are things that we are deploying today across, I think as Mark indicated, we have about 2,000 spots out there in the world doing useful things like this, and AI is becoming an increasing part of that. And then finally, Mark showed this to you. This is our little teaser video of the next generation robot we're working on, the electric version of Atlas. Again, the future for this kind of technology really is powered by AI. We're going to have these robots figure out what to do, principally, at least initially, in manufacturing tasks. I think you saw the examples of Atlas working in a simulated car manufacturing environment. The way to do that and to accelerate that capability really is through the AI programming methodologies. So I'm excited that we're leading into a panel that I'm on, and I think Spot is going to join us off to the side as we discuss some of the aspects of what we can do in the policy environment to really boost and amplify these kinds of innovations for the benefit of industries across the country. Thank you very much, and look forward to seeing you afterwards at the reception. Spot will be around there if you want to kind of take it for a little spin yourself. I'm happy to show you how it works. Thank you very much.